All right, another day, another video. So in today's video, we are going to continue where we left off last time. Last time we did the authentication piece. So in this video, we are going to create a GUI for that authentication and also integrate with GraphQL. So this is what we're going to build. Last time we had finished up creating the menu with these menu items. So I'm going to build out a component that is responsible for logging in and logging out. So I mean, the final version is going to get, cleaned up from this, but as a basic UI to log in, this is what it's going to look like, at least for now. And so what I want to do in this video is, first off, I want to show you how I refactored the code. And just so you're aware, I basically coded up the entire thing pretty much. Tested it to make sure that it's working, because I don't think really it's that valuable to just watch me typing. So let's start with actually, let's go back here. So this is the HTTP vertical, the thing that sets up our HTTP service and the routes that are involved. I've cleaned up the code, refactored a bit to make it more readable. As you recall, I am using Kotlin and the Kotlin helpers inside of Vertx. So this is not an abstract vertical, it's a coroutine vertical, which enables the functions inside of it to be suspend functions. Again, suspend functions are like async await in reverse. So they don't block the main thread. They allow other code to process as the suspend function is doing whatever it's doing. So here, let me not go over this piece just yet. So here, I put in the session state stuff. So I'm using local session store. This is not a microservice, so I don't have to deal with separate clustered nodes. This is just setting up things like the cookie. This means that the cookie is not JavaScript accessible. So this is a more secure way of having cookies. Same site, I am doing none, even though true would be more secure, because I am having to use CORS because the client off of the dev server runs on port 3000, and this Vertx service runs off of port 9999. So that's why I'm doing that. I'm setting a timeout for the session. And I'm setting this secure flag in dev mode. It's going to be false. In production, it's going to be true, because sometime in the future, if you have this set to none, Google is going to basically not accept your cookie as a security measure. So that's why I am setting this flag in production as true. This is not being used because I'm finding issues with GraphQL when I turn this on. I'm not sure what the issue is. I'll investigate it more, but for now it's disabled. So this is my GraphQL setup. And I'll go into more detail later. But basically, you have the GraphQL service object, then you have the handler, and it's mapped to GraphQL, the route. So let me go into this just after we look at some of the code refactors, and I'll come right back to that. So this is the Dowel Helper. The main reason why I'm creating this is so that I can have these suspend functions so that I don't have to repeat myself with this code over and over again whenever I make a DB call. In order to have that working, I need to set up my configuration to my database, meaning the database, the port, the host, the user ID and password, which again from the last video is coming off of our config file, and then a thread pool. So these are initialized on the Dowel Helper initialization. I'm moving away from the companion object because I wasn't completely sold on it when I first did it. I just think this way is a bit cleaner in terms of code. So that is the Dowel Helper refactor. And then I am going to create separate repositories for pretty much each entity, each business entity. So here I have the one for user. It's going to take an instance of the Dowel Helper. And this is the call to get a user. And then once I get the user, I convert it to our user entity. The user entity is basically the same code we had before, but I put it in its own separate file. And then our authenticate, that is our authentication provider override. This is the same one that we had last time. It's pretty much exactly the same code. As I mentioned before, I'm using bcrypt to do the password comparison. And then I moved out the user object, which was here. So those are my main refactors. And then the reason why I want to show you this in a little bit is I want to review this data fetcher stuff first. And for those of you who are not familiar with GraphQL Java, let's go back here. So you define a GraphQL schema. This is always going to be the same no matter what system you use. So even if you did this in Node, if you have the same entities and the same queries and mutations, it would look identical because it's a standard query language or schema language. So you need that schema, you grab it, and then I have a bunch of helper code, helper functions that stitch the schema to the resolvers, which get the actual backend data from the database. And then again, the handler handles any calls to GraphQL, the route. So here is that code. So that first call that we were looking at is going to wire, as GraphQL Java calls it, our schema to resolvers, and then create an instance of GraphQL. This was in all this stuff was in my GraphQL video, so if you find my explanations this time a little too fast, you can just watch that video. I'll have a link in the description. So here I am doing the stitching with the schema, the string schema, and then this resolvers, which in GraphQL Java is called data fetchers, and then they're being stitched and an executable schema is created. So here it finds out what you're trying to do, in this case a query, maps the actual query itself, in this case get logged in user, to a specific data fetcher. The data fetcher is the same thing as a resolver, which goes to the database and gets the related data. So this is the mapping. This is the same mapping but for mutations. So if I had other mutations, I would just put them into here, whatever the other one is and whatever the other one is. So if we look at our actual data fetchers, again, I cleaned up the code somewhat, getting away from companion objects just because I think it's cleaner code. So let's investigate the login data fetcher first. So it's a data fetcher. I am creating an instance of our PG auth provider. All the data fetchers expect a completable stage, I think it's called, which is the interface version of completable future. So that's why I have that here. It completes or it fails and then it gets returned. So I take the parameters, I convert it into a JSON object, and I pass it to our authenticate function from our PG auth provider before. So then once I do that, I get the routing context, and assuming that this call was successful without exception, I grab that user, I grab the user object, and then I set it to the routing context user. Here is just a check, and then I complete and I pass that user. If it fails, I exception out, and that's the login. So again, it's happening all within GraphQL. And then if it's successful, I am taking that, I'm making an additional call to get the logged in user. And I mean, I'm going to refactor this code more, but just for testing purposes, I'm making sure that this is in there based upon this, right? So later on, I'll add additional checks for expired and things of that nature just to make sure. But anyway, so this is a check. I return on success. I fail out if it's not successful. So that's the core code. But what does that have to do with CORS? So as I said before, I have, for development purposes, React running on port 3000, and then I have the service running on port 8888. So I need CORS for everything to work. Now this was a serious pain in the butt, and I'll show you more of why later. But one of the issues is you have to send this as a header in your response. So, or else it doesn't work, because you also need to send this from your client side to include the credentials coming in from the client. Credentials means basically your authenticated session cookie, by the way. But if this is enabled coming in from the client, then this has to be returned from the server. Okay, but GraphQL doesn't by default return that. It has no notion of request response or authentication or anything like that. So you do get this context and then the session inside of it and the user inside of it and all of that kind of passed in as environment data by Vertx. But the issue was that even though I was putting in this in here, for whatever reason, it was completely ignored. So I just kept getting CORS errors on the browser that my calls were being rejected. So what it turns out, and this took me like a day and a half of investigating, but it turns out you need this in your CORS handler set to true, or else this thing, access control allow credentials set to true, is never going to get passed. So that was very painful. But basically, so the backend stuff I got working after I added that. So then the front end stuff is, again, on the Apollo client, you have to pass credentials. Credentials, again, is basically the session cookie, right? Assuming it's properly created. And then, of course, you have your Apollo provider taking the Apollo client and passing that data, whatever it may be. So, as I said, I am having this GUI. It's going to be a modal to log in coming off of this button right here. I'm going to have an inverse button for logout. So I'm creating this as a component. It's going to be in our desktop nav menu. I'll take care of the mobile menu later. But basically the component is this. And it's pretty much what we had. Actually, we didn't go over this in the last video. But so this is an Ion modal. Again, we're using Ionic only for GUI purposes because it's got a lot of nice design themes out of the box. But so we're using a functional component in order to use hooks. By the way, I don't do this normally. This is definitely going to be a child component. I like to keep my state for children inside of a main parent component. In this case, it would be the page or the relevant page. So again, this will be refactored out later and come in as props. But for now, whether it's open or not is coming in as a prop. And then these are going to get reused in various places later. But the core UI is Ion modal. Inside of the Ion modal, I have a list of items. List of items. First one is a label and the input. Label, input for the second. Then we have buttons. And we have another list. I'm not sure what I'm going to do here for final, but for now, I wanted to just display the name, the logged in name. So if we go to the top, the first thing we want to do is we want to try to log in, passing in our username and password. This is a refresher of data because GraphQL by default will cache its query results. So this guy may need to be refreshed after a new login. So that's why I have this here. The check for successful login after the login actually happens is to go and get the logged in user, which is what I showed you before in the data fetcher. This is a lazy query, meaning I don't do this straight off the bat. I wait till this happens first. So when this happens, by clicking on the submit button right here, I see if there's data. And if there's data, I display it. Then I attempt to get the logged in user. If the getting of the logged in user is successful and this changes, then this use effect will trigger. Then I will update and present this message down here. These are just typing events to update the value. So that's basically it. So if you look at application, you can see that we have no cookie, session cookie. So I'm going to refresh the page. For testing purposes, I just hard-coded the values in here. So as you can see, a new cookie was created. Cookie name DZ Haven cookie. So you saw the print, the console.logs from before on the client. If login is a success, the login object, or at least whatever my query or mutation is getting back, I'm just getting back the username only. But in the case of get user logged in, get logged in user, I'm getting both of these guys. So I do that, and then if it's successful, I execute get logged in. This thing will refresh, and the logged in user object will be console.logged, and a welcome message will appear. So again, the ID, the username, and then the welcome message. So this was a pretty fast demonstration, but this took me days to do, not because the code is particularly complicated, but because I am having GraphQL and CORS and session state. And by the way, I'm not using Redis because I don't need it. Since Vertx is supplying session state, cookies, all that stuff, it just felt redundant to have an extra service. So I'm probably saving a little bit of memory, certainly a little bit of complexity by not having an additional service that I need to configure and update and maintain. But anyway, the documentation for the for each independent thing, I would say is okay, but for the kind of aggregated use of all of these things together, the documentation is shit. It's basically non-existent. So things like this, you know, it's not in the documentation. And whatever, it is what it is. So be aware that, what was the other one? If you're using CORS, you must do this. Otherwise you can get, at the very least, strange warning messages about CORS, or even failures outright when you're using a browser on a dev server that is different from your main server. remember this. This number one is only an allowed header. It is actually not passing the header. It just allows the passing of the header. And you have to pass this, but through this, right? You have to allow credentials. Again, allow the header of credentials. Trying to do it in here through the routing context simply does not work. So those are the key things inside of here. I also did want to mention that as you can see here, we are using suspend throughout, right, for performance, asynchrony, and also because it's a best practice inside of Vertx so that you do not block the event loop. However, when you do that, when you use suspend functions, obviously you have to use coroutines, because suspend functions, for example, this suspend function right here can only run inside of a coroutine. So please remember that you want to have the coroutine scope as the Vertx dispatcher and not one of the Kotlin thread pools, because then you are making unnecessary use of multiple thread pools, and that may cause some weird issues, contention, whatever. So you want to make sure that you use the Vertx dispatcher in all your coroutines. In fact, it might even save a little bit of memory to do so. I don't believe I have coroutines inside of here. Yeah, I don't. But when you are using coroutines inside of a Vertx app, you definitely want to make sure you are using this scope. And then on the client, this is the most important piece right here in regards to CORS, GraphQL, and session state. If you don't have this, what I found is that your cookie will never get created. It just won't. And even if you manage to create it, it just ignores it completely. All right. So that's it. Thanks.